Hi, everybody. It's Professor Ken again, and the video conked out on me right as I was on the ninth step of problem number 4. Um, what a darn shame. So I'm going to share my screen, and I'm not going to redo problem number 4. I'm just going to rehash it. I'm also going to stop my video so my good looks don't get in the way. Okay, so what did we know? We know that 20 out of 100 children who were exposed to secondhand smoke developed the asthma. We know that 10 out of 135 children not exposed to secondhand smoke developed the asthma. And we're trying to test with an alpha, with a confidence level and a significance level of 0.10, whether or not children exposed to the secondhand smoke are more at risk of getting asthma. So our N1 was 100, X1 20, and P hat 1, 20 out of 100. For the non-exposed kids, N2 is 135, X2 is 10, so P hat 2 is 10 out of 135. Our null hypothesis is P1, which is those exposed, minus P2, which is those not exposed, is equal to 0. And the alternative is that those exposed are greater than those not exposed. So P1 minus P2 is greater than 0. So we're trying to prove that P1 is greater than P2, or that P1 minus P2 is greater than 0. So when we put our value into the Desmos, it was a right-tailed test. The critical value was 1.282. And the test statistic Z was 2.86. So since the critical value is 1.282, if Z is greater than 1.282, reject. If Z is less than that, fail to reject. Z is 2.86, so we rejected the null hypothesis. So what's our final proof? Children exposed to second-hand smoke are at greater risk of developing the asthma over children not exposed to the second-hand smoke. All right, good times. Okay, let's go on now to problem number 5. It's a spin-off of problem number 4, so we may be using some of the same material. So for the 100 children in question 4 exposed to the secondhand smoke, their mean heart rate was 75.5 with a standard deviation of 6.6. For the 135 children not exposed, the mean heart rate was 73.7 with a standard deviation of 5.2. Is there a 0.01 significant difference in the mean heart rate of those exposed to secondhand smoke versus those not? So let's write down our information. So we're comparing two means, and we're saying those with secondhand smoke have higher heart rates. So we're saying that mu1 is minus mu2 is going to be greater than 0. All right. So X bar 1 is equal to 75.5. S1, the standard deviation of those children, is 6.6. And N1 is equal to a 100 because there were 100 of them. Oh, these are the secondhand smoke kitties. Okay, so no secondhand smoke. Okay, what do we know? There's 135 of them, and their heart rate was 73.7. So X bar equals 73.7. What the heck is that? Get rid. Oh my gosh. Don't want that. All right. That's X bar 2. So standard deviation 2 is equal to 5.2. And N2 was equal to, how many were there? 135. All right, and our alpha is 0.01. So since we think the secondhand smoke kids are going to have a higher heart rate, the claim is that mean 1 is greater than mean 2. In other words, the mean 1 minus the mean 2 is going to be greater than 0. So that's all part 1. 2. Oops. 2 is that the null hypothesis, mu1, I should really do the right mu. Mu1 minus mu2 is equal to 0. And the alternative hypothesis is that mu1 minus mu2 is greater than 0. And 4, alpha is equal to 0.01. All right, so we're comparing, it's a null hypothesis test with two means. So let's see what we have here. Null hypothesis with two means, there it is. It's a t distribution. Okay, so alpha is 0.01. And it's one tail, so we're going to get rid of the over 2. And we're only going to do the right tail, so we're going to have negative infinity over here. Yeah. Okay. Negative infinity. There it is. Okay. So our area is 0.99, which is what we want. There's our critical t value. However, it's going to change because we have to put in our correct data. So N1 is 100, N2 is 135. N1 is 100, N2 is 135. That means N has to be the smaller of the two, 100. Okay. The first mean, 75.5. And the first standard deviation, 6.6. Second mean, 73.7. And the second standard deviation, 5.2. Okay, so our critical value, we don't really need this point here, so I'm going to take it out. I don't like it. Now, our test statistic is 2.257, and our critical value is 2.365. So let's bring this over here so we can see it better. So the color of the dots match up. So there we go. I like that way better. Okay. Oh, okay. So here's our graph. And we see that our critical point is 2.365, and our test statistic t is equal to 2.26. So now we're ready to define the rules. So we will, reject the null hypothesis if t is greater than 2.365. Fail to reject the null hypothesis if t is less than 2.365. What do we know? That T is equal to 2.26, which is the same thing as 2.257. Same thing. Either way, we will fail to reject the null hypothesis. So that means we did not prove the alternative claim that the mean heart rate for those exposed to secondhand smoke is higher than the mean heart rate for those not exposed to secondhand smoke. But we did prove that the kids with secondhand smoke are more likely to get the asthma. So our claim is there is insufficient evidence to prove that kids exposed to second-hand smoke have a higher heart rate than those not exposed to the secondhand smoke. All right, good times. So that was number 5, I believe. Yeah, we only got 2 more left. Woohoo! All right, let's go to number 6. Do children who are not exposed to secondhand smoke have less variation? Test with 0.05 significance. All right, so what I'm going to do is I'm going to grab all that data. Pull it down here. Oh my gosh, why did it do that? Okay. All right. We don't need our X bars because we're only testing the variation, which is the standard deviation. So we're not going to need that. I'm going to delete it so it doesn't get in the way. All right, and our alpha level this time is 0.05. Okay, so now we're comparing 2 standard deviations, and we're saying that do the children not exposed have less variation? That means, so, right, because there's 5.2. So that means do the children who are exposed have more variation? So the null hypothesis is going to be that sigma 1 minus sigma 2 is equal to 0. The alternative hypothesis. Okay. Now, it says, do the kids not exposed have less? That means do the kids who are exposed have more? We're testing to see if S1 is bigger than S2. So that would mean sigma 1 minus sigma 2 would be greater than 0. So it's a one-tailed chi-square test. So for alpha was equal to 0.05, which we said, but now we have to formally say it again. All right, the test for 2 standard deviations. Null hypothesis test for 2 standard deviations. There it is. All right. So N1 is 100, N2 is 135. N1 is 100, N2 is 135. The first standard deviation is 6.6 and the second is 5.2. 6.6, 5.2. Now, watch how this changes. Okay, now the right critical value was going to be 0.05 because it's a right-tailed test. So let me go insert drawing. Oh, I don't like it that way. Don't like it. All right. So let's do this. Let's go to draw. And we'll make our, so this is 5 and 6. So here's our chi-square. Wait a minute, this is not chi-square, this is f. So it's a one-tail f test, not chi-square, because remember, two standard deviations is an f test. All right, so this is f. We know this is 0. And over here, we have some standard deviations. So at the highest point, it would be sigma 1 minus 1 minus sigma 2. All right, this is going to be 0.05. This is going to be 0.95. So we need to find our critical value. Let's go back to our Desmos. Okay. So the area to the left of our right partition is going to be 0.95. There's not going to be a left partition, so we'll just put a 0 there. So our right critical value is 1.36. This is 1.36. And our our test statistic is going to be right here, 1.61. All right. So now we're ready to set the rules of the game. Insert a page break. So reject the null hypothesis if f is greater than 1.36. Fail to reject if f is less than 1.36. What does f equal? 1.61. F equals 1.61. That's greater than 1.36, so therefore reject the null hypothesis or hope. So what does that mean? We proved the alternative hypothesis, which is the standard deviation for the kids. Well, really, if we want to go back to what the claim is, do the children not exposed? So the children who are not exposed to secondhand smoke have less variation than the children who are exposed to secondhand smoke. So the kids not exposed to secondhand smoke have more variation in their heart rate than the kids who are exposed to secondhand smoke. All right, last one. Woohoo! All right, so a Gallup poll of 19,600 employees showed that 49.2% are actively searching for new jobs. Use 0.05 significance to test the claim that less than half are looking for new jobs. All right, so we're doing we're testing a proportion, so it's going to be a Z distribution. So what do we know? P hat is equal to 0.492. N is equal to 19,600. P is equal to 0.50, 50%, because that's what we're testing. And alpha is equal to 0.05. Now it says use 0.05 to test the claim that less than half are looking for new jobs. So we want to say that P hat is less than 50%. So it's going to be a left tail z-test. Okay, so step 2. Our null hypothesis is that P is less than 0.5 or 50%. The note equal to. I've been doing that all day, but I've been catching myself all day. So step 3. The alternative hypothesis is that P is less than 0.50. Step 4. Alpha is equal to 0.05. All right, so we're testing a proportion, not two proportions, just one. We'll go here. Okay, null hypothesis testing with proportions. All right, it's a left tail test, so we're going to go from negative z to infinity. Alpha is 0.05, so therefore we don't want z over 2. So our area is 0.95, which is what we want, and our z-score is going to be negative 1.6. Our critical value is negative 1.64. All right, what was the value of p hat? 0.492. What's the value of TP? 0.5. What's the value of N? It was a big one. 19,600. So our critical value, I'm going to put a negative z here so we can see our critical value better. Okay, so our critical value is negative 1.645. And our test statistic is negative 2.24. So let's copy that. Works out very well for us. So here's steps 5 and 6. All right, so our critical value is negative 1.645. And we see that our test statistic z is equal to negative 2.24. All right, so we're ready for the rules. You will reject the null hypothesis if z is less than negative 2.24. We will fail to reject the null hypothesis if z is greater than negative 2.2, not negative 2.2, negative 1.645. My bad. Negative 1.645. Okay. Now, what do we know about z? Z is equal to negative 2.24. Negative 2.24 is less than negative 1.645. Therefore, we reject the null hypothesis. So what can we've proven the alternative. What is the alternative? Is that the proportion of job seekers is less than 50%. So fewer than 50% of employees are actively looking for another job. Okay. So now we have, I'm going to stop my share. Turn on the video. Hey, I'm back. Okay, so we finished all 7 of those problems. You have extensive videos for each of those problems. It's a good thing. And we will have office hours Sunday at 5 p.m. Unless you hear from me otherwise. All right, very good. Bye now.